Hi Joyce. So Amanda Debesaurian came in earlier today and she said that she would love to see questions on, actually I should say hi Amanda Johnson and George and Deb and Joyce. So I had Jackie and Gerardo, because they hadn't finished all the way up to number 6, I had them go ahead and just do number 6, specifically so that we could go ahead and go over the question. Amanda Debesaurian was just like, oh, let's go over all of it. So they just finished it. Joyce, if you want to, or the rest of you guys, if you're watching, if you haven't tried it yet, go ahead and try it first. And then we're going to go ahead and go over questions right now. So pause me if you haven't tried it yet. And try it first, and then we'll see how we're doing. For 2012 FRQ number 6. Let me go ahead and get the answer key up first so that you guys can grade it. Oh, this is the question for number 6. Do I have the answer key built in? Yes, I do. Alright, so let's start with grading. And we'll start with part A because that's the big one. So I'll try to zoom in on that so you guys can see it more clearly.
Oh, Dumbo, forgot the test endpoints.
Interval of convergence.
That's the only time I've ever forgotten to do that.
Struggle. You were close. It happens every now and then. You're just going fast, trying to get it done. Okay. And I think Adeb had some questions on it. Like she had already tried it and graded it. So let's go ahead and talk through the answer key as well. So in letter A, they were asking us, it looks like a ratio test? Nope. Just finding the interval of convergence, right? Using the ratio test, okay. So using the ratio test, they give us an alternating series up above, infinite alternating series, determine the interval of convergence 4. So then using the alternating series test, remember that you have to plug in n plus 1 for n. But the one thing to keep in mind as you're plugging in, just real quick, is that that 2 does need to distribute when you plug in the n plus 1. That's one place where a mistake could have happened. And if you plug in n plus 1, distribute the 2, then you will get this 2n plus 5 on the bottom, and you will get this 2n plus 3 up top. And as you multiply by the reciprocal, they do the absolute value part first. You could obviously go ahead and write in the limit before and then have the less than 1. They do it all separately, but you can do it all together. So you could have written the limit right there, and then you could have written the less than 1 right there, and then you would have had what we usually do as far as our solving. The limit as n goes to infinity of this is really easy. You just have 1 times x squared is x squared. And then remember, as you use square root, you have to think plus or minus square root. Less than, it's going to be included to. So you basically just need to think about, just in case you want to remember the inequality stuff, x is going to be less than 1, and then when you do the negative square root, you can think of it this way. This is the positive square root, and then this would be the negative square root. When you move the negative to the other side, so this is x less than 1, then that inequality would flip. Yeah. You would divide by the negative, the inequality would flip, and then you would square root. Although the struggle with that, plus or minus square root, I have it on the wrong side. I totally have it on the wrong side. Because you would square root this side as well. Plus or minus square root of 1. I don't know, the way I usually remember it is just when you square root plus or minus, when you take the negative 1, the inequality flips. That's the easiest way. We can also test numbers if worse comes to worse. And so you do have the interval of convergence, and so far, right now you've gotten setting up the ratio, computing the limit, the interior, there we go, is the negative 1 to 1. But if you don't do the last 2, if you didn't figure to, or remember to consider the endpoints, then you would have lost those 2. Remember, when we do consider the endpoints, they actually need to see you showing what test you're using, and I would say why. So for instance, I don't know. I think you guys could improve on this answer as far as why the alternating series test says it converges at -1 and 1. What would your rationale be? What would the alternating series test need in order to say, yes, the series converges? Yeah, you could say, first of all, that a sub n plus 1 is less than a sub n, which means that the terms are decreasing. Or another way of saying it is we could say the limit as n goes to infinity of a sub n is 0, right? For the alternating series test, not for, obviously, any series. If it was any series, we just say we know nothing. But alternating series, we can say, yes, it converges. Conditionally true, but it will converge at those endpoints based on, I think the rationale is the same for both. Hence why they went ahead and made it equal to in all of those. Okay, so then for letter B, before we check it, you were asked the Maclaurin series for G evaluated at 1/2 is an alternating series whose terms decrease an absolute value of 0. So giving a lot of background. Is G up above? Oh, that is G, okay. The approximation for G of 1/2 using the first two non-zero terms, which would be just the first two up above, is 17 over 120. Show that this approximation differs from G equals 1/2 by less than. Approximation differ, that'd be error, right? By less than 1 over 200. Well, this is an alternating series, so can't we use an alternating series bound? And isn't that exactly what they did? However, what was a little tricky in here is that they gave you the approximation. You didn't have to find the approximation. They gave you the approximation, so if you were writing your actual if you were writing your actual minus your estimate, they went ahead and plugged in. I don't think you necessarily would have had to have write that. You could have done, because this is their version of talking about the actual, this is their version of talking about the estimation using the first two terms. You could have tried to use some sort of notation for that. You could have just said error if you wanted to, I suppose. The absolute value of the error is going to be less than.
I put therefore the approximation of G of 1/2 is less than 100.
Oh, I was just talking about as far as setting up the error bound, because they plugged in the 17 over 120, and I don't think that's necessarily needed for the point, but you could. But you basically just need to plug it into the next term being x to the 5th over 7. Plug in when x is 1/2. And the nice thing is, do you guys actually have to simplify that? No. So couldn't you have just done 1/2 to the 5th over 7 and say, I sure hope, but they said it for a reason, right? That's totally valid. That would have gotten you the point, because then you would have gotten 1 point for that and 1 point for, we'll just say you realized that, whether or not you actually did all the math. That's okay. Huh? To make sure that it actually works. I just know that some of the ones that we've seen have been pretty complicated. That one 2 to the 5th wouldn't be that bad because it's 32 times 7, but in other ones it's been pretty nasty as far as solving. Oh, I did 2 to the 5th earlier, Jay. Letter C, write the first three non-zero terms in the general term of the Maclaurin series for G prime. Well, that's not bad because we have G up above. Remember G prime, all we got to do is go ahead and take the derivative term by term because it's like a polynomial. And so then all we were doing was a lot of power rule. So then power rule for the first term, second term, third term. The tricky thing probably would have been the general term. Maybe you could have kind of used some of the stuff from up above in the sense that they did, ooh, they didn't give you the general term.
Yeah, they did. You sure I didn't get that?
Oh, they did give you an expression. They did give you x to the 2n plus 1. I was looking at the end of the series, sorry.
Right.
But that's not the general term. That's called the a sub n, or the arbitrary term. So then you can go ahead and, now that you've taken the derivative, what's different or what's new?
Well,
The 2n plus 1 does come down. You take away 1 all over. Yeah, you can basically just use the a sub n formula. Just think about the derivative and what ends up happening. So hopefully that wasn't too bad, as long as you kept an eye on that a sub n formula up above. If you just tried to do it from that, yeah, that wouldn't be very fun. Except, yeah. Except, I mean, odd numbers, it always is 2n plus or minus something odd, because that's how you start with an even number, add 1 or add any other odd, subtract 1, subtract any odd. That's how you get the odds. So you could have maybe been able to figure that out if you knew how to make odd numbers. Bless you, bless you.
Thank you.
X to the 2n shouldn't have been too bad, negative 1 to the n wouldn't have been too bad, so hang in there, but use that a sub n up above. Gerardo and Jackie, what was your score roughly?
7.
7 out of 9? 7 or 8, something like that, okay. Adeb, hopefully that answers your questions. Since that was the only one that was specifically brought to my attention, and I think Jackie and Gerardo both have some to still finish. Gerardo's on 2 or 3, Jackie on like 4 or 5. 5? Okay. We have about 15 minutes left of class.
Oh, that's how you were gone for forever.
Yeah,
I totally forgot.
yeah. I was back in here by like 11. We can go ahead and just work on whatever FRQs you guys need. Tomorrow we'll go over questions, but if you guys don't mind, maybe you could grade it tonight. Using the answer key, I think it should be online. Mr. Calculus has it, or if you guys realize these answers are at the end of my notes. If you just go on the 2012 that's posted under class notes, you can access it there. Gerardo, go ahead, you had a question, but.
2C calculator is making me cry. Like, that's ridiculous. That's a ridiculous derivative. Like, I'm really not sure I'm doing that right.
Particle position, we have vectors, just times zero. Bless you, we have an initial position. And then we know dx dt and dy dt.
Yeah.
Okay, what are we supposed to be doing for 2c?
Well, find the speed. I found the speed very quick. When I find acceleration, I was like, okay, I need d squared x dt squared. D1, whatever. D squared y dx squared. So I did dy dt over dx dt. So I got e to the t sine squared of t all over square root of t equals 2, and that's supposed to be derivativized. And it's all over square root of t plus 2 over e to the t, which is dx dt. I did all my stuff. But
This is a calculator problem though, right, bud?
I'm not entirely, yeah.
So if it's a calculator problem, you don't actually need to derive anything by hand.
That's what I was thinking. Like, do I need to just plug
Now,
in?
if it was a second derivative, if they gave us only the original function, we'd be in trouble, right?
Right.
But since it's just one derivative beyond, couldn't we just go ahead and use our n-derived function in our calculator?
Yeah, that's the thing that's bothering me. Like, do I plug in? Where do I plug in t? I think, I just figured it out.
What's wrong? What were you stuck on?
I was like, wait, t goes here, but doesn't go here. If I'm supposed to plug in 4 on the bottom and just plug in at 4 on the top of the top.
No. Do you know what I mean by use your calculator to solve the derivative?
Yeah.
Because you shouldn't be plugging in 4 at all.
Yeah, that's what I was doing. But then all of a sudden I was like, wait, what? I don't know. Like, oh. Dumb.
But I mean, like, actually taking the derivative. Like, there's no plugging in a 4 besides putting a 4 at the very, very end in this box. Because you can do ddx of, right? There's no place to plug in 4. You're plugging in the function. Oh, I just did the wrong one. I should use my shortcut, but that's okay. So I can do ddx of, and then I have my square root of x plus 2. The t is irrelevant just because the calculator doesn't know what context, it just knows to solve for the derivative. This would definitely be something where they would just put an answer, because you need to be able to use your calculator to solve for derivatives. No, not 4. Specific derivatives.
So that's just the x.
Mm-hmm. So what are we going to do next?
Oh, you see what I was doing is I was doing the full on
I know.
exponential vector, you idiot! Oh, I didn't even read the vector.
That's what I was saying, use your calculator. You know what I mean?
Yeah, no, I was using my calculator, but I was doing dy dx, not individually. Ah, I get it.
Oh, you were doing parametric.
Yeah, I was doing full on, yeah.
Parametric. Okay. Yeah, that's why I was showing the side carrots.
That makes more sense. Okay. I thought that was too complicated. When it says find a distance travel, does that mean total distance?
Hold on, I'm writing this down, sorry. 9, 8, 9. And they're not labeling any units or anything. But that was only one part of the answer because you were saying you already done speed up above, right? Okay, so I'll just write speed and then it is what it is. Find the distance traveled. Distance traveled by the particle from time d equals 2 to t equals 4. I would naturally assume displacement because they didn't say total. It'd be a little awkward if they meant total and didn't specifically say it. It's possible, I just don't like it if they did. That would stink. Nope, they told us in trouble. There was an AB question earlier today. Hold on.
How would you find displacement? Would you just do the separate, would you just do the vector?
How many meters did this particle travel? Should this have been total distance traveled then?
What would the answer key say?
My answer is right. Maybe there's no intersection between 1 and 8. Because if it was absolute value, we'd have to find the zeros of the function, and then we have t to the 1/3. Well, that's interesting. Maybe I should have done total distance travel, because it's similar wording.
What should the answer key?
Oh, I just did. It's the integral of speed, which would be total distance traveled. I'm trying to compare the wording as far as when they do or don't use.
So it is displacement.
Isn't total distance traveled the integral of speed?
Yeah. I need to look at the other. I don't know how to do displacement with that parametric off the top of my head.
It's because there's no nice formula for it. Because you would have to do change in x's and change in y's. It would be a vector expression. Maybe that's why we know it's total distance travel, because it's specifically vectors.
If exam review, right? Where's the answer key guys?
2012 member research AP Mr. Calculus, or you go under class notes because I have the answer keys at the end. But I just had it up, Gerard. Remember I just showed you? Right here.
I can't see it.
You can't see speed? Oh. Speed? It's right there.
Yeah, you got it right. Thank you.
Mm-hmm.
Oh no, no more calculator. Goodbye.
t would equal 0, which is an in-between, and then t would equal negative 5/6 cubed rooted. Ooh. I guess either way you look at it, here's the struggle for the problem I put on the board. The zeros wouldn't be in between the interval. So there is no difference between total distance traveled and displacement in this one.
So it was the long way around?
Well, I was trying to figure out, because based on how that question went with vectors, I mean, vectors we really only have a nice formula for total distance traveled. Displacement would be like a change in x, change in y, do the intervals separately. But in this one, how many meters did the particle travel? I assume displacement. But then thinking about the way that that last question was worded, where they didn't put total distance traveled, how many meters literally did the particle travel could be absolute value. But the problem is when I went to go solve the absolute value, there's no place to split up the bounds, so it's going to end up being the same answer. So whether it's it's going strictly in one direction, there is no backtracking. So it's not going to make a difference whether you do absolute value or not. So I don't know. It's an interesting question. So obviously they don't always say total distance traveled when that's what they want. That's a good question. Yeah, I think almost all the questions actually have that. They put total distance. I'll have to look in the AP teacher and see if I have any hints about wording. I don't know. What? You can play Jeopardy live? Go team. Anyway. Alright guys. We'll go ahead and go